Hi everyone. Today we are going to talk about rigid transformations in the coordinate planes when we have two-dimensional figures. So, to review, we have a transformation. A transformation is an operation that maps an original figure called the pre-image onto a new figure called the image. When we have a rigid motion, that's a transformation that preserves size and shape. All corresponding sides and angles of the pre-image and image are congruent. This is also known as isometry. And examples of rigid motions are rotations, reflections, and translations. So we're going to start by looking at rotations. Okay, let me just pull that up. So rotation is a turn around a fixed point called the center of rotation. The figure rotates at a specific angle and direction. Most commonly, we'll be rotating from the origin, but you can rotate over any coordinate. The rules for rotating points about the origin: 90 degrees. Your point xy now becomes negative yx. 180 degrees. Xy now becomes negative x, negative y. And then 270 degrees, now xy is y, negative x. So we're going to practice doing a few of these, graphing and labeling each image under the given rotation about the origin, and identifying the coordinates of the image. So if I had triangle LMN with these given vertices, I want to now rotate this figure 90 degrees counterclockwise. So 90 degrees counterclockwise, if we think about how a clock moves in this manner, we want to move in the opposite manner. So that's going to be moving this way. So our triangle should be somewhere here in the fourth quadrant. So if I'm rotating 90 degrees counterclockwise, that means that my rule is xy becomes negative yx. So I'm going to apply that rule to all three of these vertices. So my y value goes first and the sign changes. So for L, that would be positive 5. And then my x value just goes at the end. For M, the y value goes up front and changes sign. So that'll be positive 2. And then the x value just goes at the end. Y value goes up front, changes signs. X value just goes at the end. And all of these points would end up in the fourth quadrant, just like we want. So we have 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5. That's going to be L prime. M prime. And then N prime. So this is my image. This was my pre-image. And I just spun it around the origin. 90 degrees. Okay. Now I'm moving this parallelogram, rotating this 270 degrees counterclockwise. So I see my rule here. XY becomes y negative x. 270 degrees counterclockwise. So remember, this would be clockwise, counter, 90, 180, 270. So I want to end up in this quadrant, again, in the fourth quadrant. So I should have positive x values and negative y values. All right, so my y value goes up front, 5, oh, my comma there, -2. 7, -7. 4, -6, 2, -1. And now I'll just plot those points, get the visual. Since u is closest to the origin, you should stay closest to the origin, 2, -1. That's u prime. Yep, and that's about right. R prime, 5, -2, 3, 4, 5. R prime. S, 7, 2, 4, 6, 7. That's S prime. And then T prime, 4, -6, 2, 4. T prime. So notice this is still a parallelogram, still the same shape, same size. I'm just rotated now. So R moved all the way here, T all the way here, and S all the way here. 270 degrees counterclockwise. All right, now I have this quadrilateral that I'm rotating 180 degrees. I know my rule for that. XY becomes -x, -y. 180 degrees, clockwise, counterclockwise, doesn't matter. But I should be in the second quadrant with -x and -y values. So I'm just changing the signs for both of these. So instead of +2, that's -2. Instead of -3, that's +3. All right, so I have a -x value and a positive y value. Yep, and that's what I see here. So I'll just plot those points. Oh, that's 5. Oh, she got to be up one more. Sometimes counting's the hardest part. All right, that's my quadrilateral rotated. So B comes all the way over here, C, and then A and D are still kind of on that similar line there. All right, and then here I see that this is 90 degrees clockwise. That's the same as 270 degrees counterclockwise. So you have to translate that first. If I were to go 90 degrees in the direction of the clock, that would end up here, the fourth quadrant. If I went 270 degrees counterclockwise, that would be 1, 2, 3. So that's why I'm ending up in this fourth quadrant. And then again, the rule for that, xy becomes y -x. So that's 7, -5, 1, -8, and 0, -1. Again, those values will be in the fourth quadrant, just like we predicted. So 0, -1, L prime, 1, -8, K prime, and then 7, 1. So that's J prime. All right. So we just rotated that 90 degrees clockwise. So that's our intro to rotations. Now we're going to talk about reflections. So a reflection is a flip over a line called the line of reflection. Each point and its image are equidistant from the line of reflection. So the rules for reflecting: over horizontal and vertical lines, we count to the line and count again. Should be double. We'll talk about what that means. When we reflect over y equals x, xy becomes yx. We just switch those values. And then xy over y equals negative x becomes negative y, negative x. Just a reminder, that's what y equals x looks like, and that's what y equals negative x looks like. Okay. So let's practice. We're going to reflect each figure in the given line and identify the coordinates of the image. So I'm going to reflect this triangle over the y-axis. So first I'll just trace the y-axis. So Q is 1, 2, 3, 4 away. So I'm going to go 4 in the other direction. 1, 2, 3, 4. Now that's going to be Q prime. So my y value is the same, but my x value, I changed 4 more. So I added 8 to that, so that's 4, 1. Okay, R, 1, 2, 3, 4. 1, 2, 3, 4. So now this is R prime. In R, my y value stayed the same, but I moved over 4, really went left 4, and then left another 4, so I'm subtracting 8. That's negative 4, 6. And then S is at 6, negative 1. 2, 3, 4, 5, 6. So I have to go left 6 and then left another 6. So subtracting 12 from that, negative 6. Nice, love when that happens. So I subtracted 6 and then another 6, so I'm at negative 6, still negative 1, and that's S prime. All right, and then I'll just pick a different color so this will stand out. And that's the reflected triangle over the y-axis. So it's totally fine to do that over a line that goes through the figure or the pre-image. So now I'm reflecting this rectangle over the line y equals negative 2. So that's down here. So D is only 1 away, so I'm only moving it 1 away again. D prime. So my x value stays the same too, but my y value, I have to subtract 2 from that. Negative 3. 1, 2, 3, 4. 1, 2, 3, 4 more. That's C prime now. So C prime is still at 3. And then I'm just subtracting minus 4 again. I'm subtracting 8 from 2, so that's negative 6. A, 1, 2, 3, down 3, so I need to go down another 3. 1, 2, 3. So that's A prime. My x is still negative 4. I'm subtracting 6 from my y value, so that's negative 5. And then B is last. 1, 2, 6. Went down 6. So I have to go down another 6. 1, 2, 5, 6 right here. That's B prime. So that is at negative 3, negative 8. All right, and as we can see, it flips over because the point D stays closest to that line of reflection. B is the furthest away. Okay, really important that you label those vertices in the image so that they line up. All right, now we're reflecting over y equals x. So remember that rule. We switch the x and y values. I can sketch that line too so we have a visual of what that looks like. So that's just the parent linear graph, or parent linear line. Linear line, you know. All right, so here I think it's just easier to write those ordered pairs. So instead of negative 7, 3, I'm going to have 3, negative 7, 6, negative 3, negative 4, negative 2. And now I'll just plot those lines, plot those points. All right, A prime. Six, negative 3, 1, 2, 3, 4, 5, 6, 1, 6, negative 3, B prime. Negative 4, negative 2, 2, 4, 2. Something not adding up for you. Doesn't this look smaller? 3, negative 7, 6, negative 3, negative 4, negative 2. There it is. Negative 4, negative 2. C prime. There it is. Beautiful. All right, and then finally we're reflecting over y equals negative x. So xy becomes negative y, negative x. So we switch their spots and change their signs. So that line is approximately there. So that's what I'm reflecting over. Switch their spots, change their signs. Negative 5, 0. 1, negative 5. 6, negative 3. And plot. D prime. E prime. F prime. Connect. Oh, make it better, maybe. F prime. And I reflected over y equals negative x. Awesome. All right, so since we went in reverse order of difficulty, this is the last one. Translations are the ones you might be most familiar with. When we translate, as you can see in this figure here, that means that we are horizontally or vertically sliding a figure. So the coordinate notation for that is xy becomes x plus h, comma y plus k. So h represents the horizontal shift, while k represents the vertical shift. Okay, so now we'll just practice that here. So this just gives us the rule of what we need to do with these original points. So that means I'm subtracting 3 from all of my x values and adding 2 to all of my y values. So I'll just subtract 3 from all of these first. And now add 2 to the y values. And now I will plot -7, 3. So that would be q prime. Another way I can do this is that tells me I'm going left 3, up 2. So here I'm going left 3, 1, 2, 3, up 2. So that's r prime, and here 1, 2, 3, up 2, s prime. So it should make a cool little shadow. All right, and here xy becomes x, y minus 4. So that means all of my x values stay the same. And my y values I'm subtracting 4 from. So that'll be 4 to -8. So that means I'm not moving left or right at all, and I'm just moving down 4. So when I plot these points, I can just go down 1, 2, 3, 4, 8 prime. B prime, C prime. And again, notice it's the same shape, the same size. The side lengths are the same, angle measures are the same. Therefore, this is a rigid transformation or an example of isometry. All right, that's the lesson. Thank you so much. Have a nice day.